Thinking and cognitive skills. Any well-planned lesson is a vital component of the teaching learning process. It keeps the teachers organized and on track with a lot of opportunities of supporting teaching materials and of promoting a variety of teaching strategies, higher order thinking and thoughts of difficulty levels while teaching, and encourages the learners greatly in learning with the chance of increasing their interest and abilities of interpreting very effectively for more clear and easy understanding very quickly with a better attempt of sharing their opinions and ideas. An accurate creative question paper is also helpful to accelerate such learners' learning behaviors and attitudes, introducing multidimensional thoughts and ideas over the subject of matter very effectively. As a result, the learners can build confidence in expressing themselves at a deeper level than stating facts in any situation and make them enabled to face the global challenges successfully. In making a good lesson and in preparing an accurate question paper, Bloom's revised taxonomy, thinking skills, and Q-means framework, cognitive skills always play a very vital role. That is why I am going to discuss about them, focusing on the techniques of matching the subject-specific activities with the 6 levels of thinking skills and of specifying their levels of difficulty. Bloom's revised taxonomy, thinking skills. Bloom's taxonomy was created in 1956 under the leadership of famous psychologist Dr. Benjamin Bloom in order to promote higher forms of thinking induction, specifying the 6 levels of thinking skills arranged from lower order thinking to higher order thinking. It was as the backbone of many teaching philosophies and was a source of inspiration for educational philosophy and developing new teaching strategies. Eventually, Lauren Anderson, one of his students, and David Crothall, one of his partners, revised the edition of Bloom's taxonomy with more accurate and acceptable in the educational process. In 2001, this revised edition is known as Bloom's revised taxonomy. It is mentionable that only the Bloom's revised taxonomy is discussed in the training course book, participant worksheet, Quill Essentials, British Council, because of its accuracy and acceptance. In order to introduce and identify these 2 versions are respectively given below. Pyramids, Bloom versus Anderson Crothall. The pyramid of Bloom's taxonomy, created in 1956. 6 thinking skills is written here from lower order to higher order. Knowledge, remember previously learned material. Comprehension, demonstrate understanding of the facts. Application, apply knowledge to actual situation. Analysis, break down objects or ideas into simpler parts and find evidence to support generalizations. Synthesis, compile component ideas into a new whole or propose alternative solutions. Evaluation, make and defend judgments based on internal evidence or external criteria. Second one is the pyramid of Bloom's revised taxonomy by Anderson and Crothall in 2001. It is also written from lower order to higher order, remembering, recalling knowledge from memory, understanding, demonstrate understanding of the facts, applying, use knowledge in a new or novel situation, analyzing, break down ideas and concepts into component parts to support understanding, evaluating, make judgment about the value of ideas or materials, creating, put component parts together to form a new product or solution. We can remember easily the 6 categories of thinking skills of Bloom's revised taxonomy by applying abbreviated technique. To do so, we consider the abbreviated terms here. Here 1, C is for creating, 2, E is for evaluating, 3, A is for analyzing, 4, A is for applying, 5, U is for understanding, 6, R is for remembering. In order to make out these 6 types of thinking skills from higher order to lower order, the necessary measurable verbs in the book mentioned above are suggested as in the following: creating, making, designing, constructing, planning, producing, inventing, evaluating, checking, hypothesizing, experimenting, judging, testing, monitoring, analyzing, comparing, organizing, outlining, finding, structuring, integrating, applying, implementing, carrying out, using, understanding, comparing, explaining, classifying, exemplifying, summarizing, remembering, recognizing, listing, describing, identifying, retrieving, naming, finding, defining. These listed measurable verbs are not all of the possible choices for each category. We can add more measurable verbs for each of the categories. We have added some new measurable verbs for each category as in the following: creating, generating, synthesizing, preparing, evaluating, assessing, generalizing, predicting, recommending, demonstrating, proposing, analyzing, differentiating, estimating, distinguishing, scrutinizing, inquiring, examining, surveying, detecting, inspecting, categorizing, separating, discriminating, investigating, deducing, applying, executing, showing, operating, understanding, interpreting, inferring, representing, discussing, remembering, reciting, memorizing, repeating, acquiring, recording, relating. This list of verbs can act as a checklist for ourselves and help us match the activities with the right thinking skills in order to make it more clear, ensuring better understanding about the Bloom's revised thinking skills. 6 common activities are prepared from the Unit 14 of the course book, Higher Mathematics, a textbook for classes 9-10, NCTB, Bangladesh, and match with the right skill through the measurable verbs as the following table. Activity 1. Pupils are able to make real-life problems based on CQs and 3 types of MCQs at the 3 stages of difficulty levels involving probability in various situations, making level 6 creating. 2. Pupils are able to know the consequence of repetition of event from random experiment in order to measure the degree of uncertainty about the happening or non-happening of the event. Experimenting. Level 5. Evaluating. 3. Pupils can take proper decision comparing and considering the various grades of uncertainties, that is, the numerical measures of probability obtained from the given information, data, conditions ranging from 0 to 1. Comparing, finding. Level 4. Analyzing. 4. Pupils can use the different ideas and concepts about probability in order to solve the problems happening everyday life. Using, implementing, Level 3 applying. 5. Each people can explain the outcomes, sample space, sample points, different types of events, probabilities of events, etc. obtained in the throw of coins and dice, or in the random selection of each of balls, marbles, numbers, etc. with the help of probability tree, cross product sets. Explaining. Level 2 understanding. 6. Each pupil can write the sample spaces, events from the throw of coins and dice, or the random selection of each of the balls, marbles, and numbers, etc. Describing or finding. Level 1 remembering. It is not always possible to prepare a question paper consisting of MCQs and CQs with all 6 difficulty levels of thinking skills. In order to have a clear idea practically, some clues for obtaining the 6 levels of thinking skills and some creative questions on very simple stems 1 and 2 are given in the following table. Level of thinking skills. Some clues for obtaining the levels of thinking skills. Level 1 remembering. Learners can recall a formula or a statement, tell the name of objects, equations, list, order the things, mention the situations, conditions, perform simple calculations, repeat a process or a method, etc. Level 2 understanding. Learners can describe what a formula does and what a statement means, realize what a situation or a condition is, classify, match the object's equations from its properties or conditions, express a final answer contextually in the proper way, etc. Level 3 applying. Learners can implement or use the proper formula or statement for a task, solve an equation, prove a statement or a relation, obtain the shape and size of an object, determine the changes of a function or an object, etc. Level 4 analyzing. Learners can analyze statistical data, compare various methods, procedures, structures, perform calculations by changing variables, find the validity of a solution, etc. Level 5 evaluating. Learners can compare 2 or more methods efficiently, support a proof with additional information, etc. Level 6 creating. Learners can drive a formula or a theorem in a new situation, design by using geometric shapes, create geometric figures or mathematical problems, set instantly what the reasonable answer is, prepare new concepts in accordance with any requirement, etc. 10.1 ABC is a circle of radius 6 cm. Write the formula of area of a circle. How can a sphere of radius 6 cm be made with the help of the circle ABC? What is the area of the triangle ABC? If pi is equal to 22 upon 7 and the circle ABC is made into a square such that circumference of the circle is equal to perimeter of the square, ascertain whether this square is inscribed in the circle ABC. If the center of the circle ABC lies on AC, prove that ABC is a right-angled triangle. Find the volume of a solid by forming it with some equal irregular polygons where its base is inscribed in the circle ABC. Step 2. The polynomial of variables x, y and z is f of x, y, z is equal to x into y square plus z square plus y into z square plus x square plus z into x square plus y square plus thrice xyz. What is cyclic expression? Is f of xyz a cyclic expression? Justify your contention. Factorize f of xyz. If small f of x is equal to capital F of x, ascertain whether small f of x is a 1-1 function. If f of xyz is equal to xyz, show that x plus y plus z whole cube is equal to x cube plus y cube plus z cube. Consider another new polynomial of the same variables and of the same degree to form a new problem sum and justify the correctness of the problem. If someone engages himself or herself deeply on such an experiment, he or she will feel the reality of facing the difficulties to ensure all the 6 levels of thinking skills in making a question paper. For this reason, we can see that there are 3 difficulty levels in the subject of mathematics and 4 difficulty levels in almost all other subjects in the educational process of our country, with combinations of the 6 difficulty levels of thinking skills. But we all are not aware of these difficulty levels. It is supposed in general that the difficulty level of a question or a problem depends only on the number of steps of its solution. In fact, the level of difficulty will depend on the duration of answering the question, problem, on many other important factors together with it. Q-means framework will certainly help us identify the difficulty levels of thinking skills and make the accurate creative question papers. That is why we should enrich ourselves through Q-means framework as in the following way. Q-means framework, cognitive skills. Q-means framework is a framework that describes tasks in 4 difficulty levels: A, easy level; B, difficulty level; C, more difficulty level; and D, most difficulty level, depending on a partnership between cognitive challenge and contextual support. The more contextual support and less cognitive challenge given in the tasks, the easier it is for the learners. Similarly, the less contextual support and more cognitive challenge given in the tasks, the harder it is for the learners. That is why Q-means framework demonstrate how tasks can be made easier or harder in the learning content. In order to identify these 4 levels, we should know about the following key vocabularies. Number 1, cognitively undemanding task. It will need little thinking and be more mechanical, such as 1. Writing the names of the geometrical shapes in a box, rearranging the given data in ascending order, connecting all the well-known subsets of a set of real numbers with the set operational symbols, etc. 2. Cognitively demanding tasks. It requires deeper thinking and problem-solving skills such as 1. Determining the volumes and surface areas of different types of compound solids. 2. Listening to a mathematical problem related conversation on a CD without pictures or text. 3. Preparing a mathematical research work, etc. 3. Context embedded. It is a context whose language skills is supported more through the use of familiar concepts, pictures, groups, gestures, videos, realia, etc. 4. Context reduced. It is a context whose language skills is supported less with a view to represent spoken or written tasks alone, such as lecture, reading a text, worksheets, etc. With the help of these key vocabularies, Cummins framework is stated as the following 4 quadrants. A. Cognitively undemanding, context embedded, easy level. B. Cognitively undemanding, context reduced, difficulty level. C. Cognitively demanding, context embedded, more difficulty level. D. Cognitively demanding, context reduced, most difficulty level. In order to make them clear more, let us see some activities in the following table and decide which quadrant A, B, C or D they belong to. Activity 1. Determining the sum of first 50 even numbers. Quadrant B. A complex task and a familiar context. 2. Writing down the sequence of natural numbers in descending order of magnitude. Quadrant A. A simple activity and a familiar context. 3. Determining the relation of the sides of a right-angled triangle. Quadrant C. The triangle provides context, but determining the relation is demanding. 4. Forming a frequency distribution table from the given data. Quadrant C. Complex task with a definite context. 5. Establishing the relation 1 less than E less than 2. Quadrant D. Complex task without any context. 6. Solving real-life problems involving probability on various types of realia, dice, coins, marbles, cards, etc. Quadrant C. Complex task with a definite context. 7. Establishing the binomial theorem. Quadrant D. Complex task without any context. Let us now discuss about the following comparative diagram on Cummins framework, original Bloom's taxonomy, Bloom's revised taxonomy, and levels of difficulty in our present curriculum. These thinking skills, Bloom's revised taxonomy, these thinking skills, original Bloom's taxonomy. In our curriculum, original Bloom's taxonomy is considered for all subjects other than mathematics. 3 difficulty levels, easy, medium and difficulty, is considered only for mathematics. Quadrant D, number 1 creating, number 2 evaluating, number 3 analyzing. Number 1 evaluation, number 2 synthesis, number 3 analysis. And this is difficulty level for mathematics. Quadrant C, 4 applying, 4 application. Medium level is only for mathematics. Quadrant B, 5 determining, 5 comprehension. Quadrant A, 6 remembering, 6 knowledge. Quadrant A and quadrant B are together easy level for mathematics. Here the meaningful and significant word knowledge is considered in the original Bloom's taxonomy as the lowest difficulty level in an extremely wrong way. That is why Lauren Anderson and David Crothel replaced the word knowledge by the word remembering and discuss about 4 types of knowledge in their revised version of Bloom's taxonomy. According to their discussion, they are factual knowledge, conceptual knowledge, procedural knowledge, and metacognitive knowledge. And each type of knowledge has all the 6 levels of cognitive scales. In favor of these facts, a table taken from the 3-dimensional model with various combination of the cognitive process and knowledge dimension is given below. The knowledge dimensions: factual, conceptual, procedural, metacognitive. Definition: factual: the basic elements students must know to be acquainted with discipline or solve problems in it. Conceptual: the interrelationships among the basic elements within a larger structure that enable them to function together. Procedural: how to do something, methods of inquiry, and criteria for using skills, algorithms, techniques, and methods. Metacognitive: knowledge of cognition in general as well as awareness and knowledge of one's own cognition. 1. Creating: generate a log of daily activities, assemble a team of experts, design an efficient project workflow, create an innovative learning process. 3. Cognitive process dimensions. 2. Evaluating: check for consistency among sources, determine relevance of results, judge efficiency of sampling techniques, reflects on one's progress. 3. Analyzing: select the most complete list of activities, differentiate high and low culture, integrate compliance of regulations, deconstruct one's biases. 4. Applying: respond to frequently asked questions, provide advice to novices, carry out pH test of water samples, use techniques that match one's strengths. 5. Understanding: summarize features of a new product, classify adhesive by toxicity, clarify assembly instructions, predict one's response to culture shock. 6. Remembering: list primary and secondary colors, recognize symptoms of exhaustion, recall how to perform CPR, identify strategies for retaining information. There are also some minor changes in the Bloom's taxonomy, such as 1. The rewordings of the taxonomy from nouns to verbs. 2. The renaming of synthesis and comprehension as creating and understanding respectively. 3. The repositioning of the last 2 categories in levels 5 and 6. With these changes, Bloom's revised taxonomy has become very much reliable to enrich our thinking skills in the teaching learning process. Moreover, Bloom's revised taxonomy and Cummins framework are very much comparable and adaptable with the patterns of question papers in accordance with our present curriculum. They are also helpful to make a well-planned lesson and ensure a proper assessing through the best ways of planning. Finally, keeping in mind no way other than training, I should say that we should try our best to enrich ourselves with the help of Bloom's revised taxonomy and Cummins framework in order to identify the difficulty levels in a skillful way. References: 1. Thinking and Learning Skills, Skill Essentials, Participant Worksheet for Teachers Training, British Council, p44. 2. Cummins Framework, Skill Essentials, Participant Worksheet for Teachers Training, British Council, pp32 to 34. 3. Lauren W. Anderson, David Krathel, Peter Reason, Kathleen A. Cruikshank, Richard E. Meyer, Paul Printris, James Roth, and Martin C. Whitrock. A taxonomy for learning, teaching, and assessing. A revision of Bloom's taxonomy of educational objectives. Complete edition. Educational Horizons, Volume 3, Number 3, pp. 154 to 159, Spring 2005, New York Longman. 4. Cattle Deer, A revision of Bloom's taxonomy and overview, pp. 212 to 218. 5. X here. Three-dimensional model of Bloom's taxonomy updated January 2012. Center for Excellence in Learning and Teaching, Iowa State University of Science and Technology, USA. 6. Leslie Wilson, Anderson, and Cattrall. Bloom's taxonomy revised. Understanding the new version of Bloom's taxonomy, 2016, 2013, 2005, 2001. The second principle. Life sketch. I, Muhammad Rahman, was born on 1st March 1970 in the district of Dhaka. I did my BSc Honours and MSc, being graduated first or second in both degrees from Jahangirnagar University. I started my career as a lecturer of mathematics in Jahangirnagar University School and College. In 1995, I joined Kumilla Cadet College in 1998 and then served in Fozdarhat Cadet College, Feni Girls Cadet College, Rangpur Cadet College, Mymensingh Girls Cadet College. Finally, I retired from Kumilla Cadet College on 27 September in 2024 as an associate professor. I am a lifetime member and enlisted writer of Bangladesh Mathematical Society.